this episode of Finnugric Machining, well, it's not going to be the rotating welding positioner foot. It's something else. Because I ended up, well, let me show you. This is my cutting oil container. It has, this is the original package, and it has a nozzle. It's an injection needle, which I have made dull so that I don't hurt myself. Well, it works well, yeah. Well, there is one thing about this stuff. This is really expensive. Such bottle, which is about half empty now, the price at the moment in Finland is something like over 70 euros. And that's a lot for such oil. Well, I acquired lately 5 liters of that stuff, but it's in it's in a canister, in a barrel. So, I could refill this one, but it leaks also. This one is not very good. You have to wipe it clean every now and then. It leaks. I don't like that. So, what I have ended up is to replace the whole thing with something like this. This is, it's a water bottle. These are like, you can buy your refreshment drinks, a soda, so to say, from the local grocery, and they come in a bottles like this. Yeah, and this is, when it breaks, you can always replace it, throw away, and put a new one. But this doesn't have a pump, and it's not a very good idea to squeeze it like this. I don't think it likes that. So there needs to be a pump here. And that is exactly what we are going to do today. A pump for this bottle, so that you can screw it into there, and then you have a pump which has a nozzle, much like this, but it's positioned in a horizontal position, and you just, it's an oiler, nothing more than that. But yeah, there are some challenges here, and the first thing we are starting with, the cap and the thread in the cap. Those seem to be standard, so it's actually 3mm pitch, so it's 3mm pitch. So the first thing is to make a cap for this one. That's how we start this episode. So let's go on. Okay. Now I'm parting off this part from this material. I'm going to reuse this. This was some failed project, so let's part it off. Now facing this. Now drilling all the way through, and this is 15.85mm drill, and this is just to be able to accommodate a boring bar into there. So let's drill. refine this to 18 millimeters. Well, the minor diameter of this thing measured from here, somewhere like there, seems to be, well, 25. So, and yeah, the length of the thread we are going to use there is, well, I measured it, it's 11 millimeters, quite exactly. So, now this is set up in a way that when I go into there, like this, and when it stumbles the carriage stop, it's exactly 11 millimeters in. So, yeah. So now I just make it enlarge this end 25 millimeters. now threading this. The pitch is 3 millimeters per revolution, and the thread form is a little bit strange. So I try to synthesize it with this tool. But now I'm doing a chamfer here, and then a start groove in the back, there in the back. I'm running this backwards, and I'm threading it inside out, so that I don't stumble into the wall inside there. So this is one way to make it easier for me and give me some time to react. So the chamfer first. Let's see what it does. How does it look? Now just some beautification here. Finish the surface here. This surface it's quite rough, and then the corners, and finally I will part it off. Flip it around and then face, and do this same stuff for the other side. Yeah, here it is, the first part of this oiler. And I have a bottle here, and it's cruising. And what worries me a little bit here is that it's sort of top heavy. It might be an issue, because it goes down like this in the lathe. But I will make a place for that one so it doesn't. Okay. Next part will be the cylinder. This is 55 millimeter long and 20 millimeters thick piece of cold rolled mild steel. And this is going to be the cylinder. And there will be a shrink fit for the bottle nut. And in the cylinder diameter will be 14.773. Well, this is actually the minor diameter of M16/1 thread. because there will be a cap on the other end, and I will use that kind of thread to thread this cap in. So, well. Threading M16/1 thread. Yeah. cylinder, that's ready now. And we also have the cap, and this cylinder goes actually into this hole, like that. But I made it so that it first slides in easily, and then we have the shrink fit part. And well, when I heat this up to around 250 degrees, it should slip there, and then it stays there. So actually, the part that slides is 300ths of a millimeter undersize, and the part that doesn't slide is 300ths of a millimeter oversize. And this is exactly, so yeah, there you go. So next we will shrink fit that one. Yeah. Well, the shrink fit went quite well, actually. I calculated that for this piece, if you warm it up to 300 degrees, it will, the 18 millimeter hole will expand about 5 millimeters, 500ths of a millimeter. And since the interference was 300ths, it should be enough. But I was not patient enough. I didn't wait for this to really warm up to that 300. That was one. And it should have just dropped in, but it didn't. I needed to go to plan B. Well, it went well anyway. Now this is really nice. It screws there like nothing, and well, so far so good. Okay, actually, you can spoil, you can destroy your work with shrink fit. If you hesitate, this is so thin, the material, the wall is so thin that it warms up in well, milliseconds when you push it in. So you have to be really quick when you put it there. Otherwise it grabs in between, and there you are. You cannot get it out from there. I know from experience. I have done this the wrong way quite many times. You need to have the plan B available right away, because yeah, okay. No, but I guess I was lucky. And next item will be the piston. This is well, it's a 100 millimeter long piece of 16 millimeter in diameter, cold rolled mild steel. Well, as is the tradition. First we face it and then we center drill it, and after that we start turning the diameters. So the diameters here. This here is 8 millimeters, this is 10, and this is 14.7. And now I'm making a groove for an O-ring. And well, I have been trying to figure out what should be the bottom diameter be, and it should be 11.5. So 3.2 millimeters from diameter in this groove. So yeah. I also run this a lot slower, 180 revolutions per minute maybe. And yeah. So let's go. And now since we need this to be 2 millimeters wide, this is at the moment 1.5. So I need to, I need to unlock the carriage and move it at least half a millimeter. Let's zero my travel indicator here. Half a millimeter. Let's see now. That would be half. But let's take 1/10 more. So yeah. And now I just do this again and hope that this is rigid enough to be able to peel that thing off. Yeah. Yeah, it is rigid enough. There you are. Looks great. And oily. Man. Yeah. So the minor diameter of M8 is 6.466, but yeah, and how much do I leave here? Like there, maybe 1.6 millimeters away from that. Let's go and see. Well, there isn't much of a thread, but it's enough. Well, maybe if it's more than one turn, then it's okay. And now, well, I can also do this corner now. Like that. Okay. Threading this now. The lathe is off, and the lathe is in the back gear. And the tailstock is supporting my die here, and this is just do it. This really is a delicate operation, so you have to be really. Oh yeah, it seems like we can get more than one. Oh yeah, good. Very good. I have to be careful not to scratch my sealing surface there. Let's see how it did. Well, we have plenty of thread there. Let's take the other way around. This usually, yeah, it's a little bit tight, which is good. Yeah, I think that's it. That's it. Yeah, good. So the minor diameter of these is really like 6.4 millimeters, 6.46. And now when I drill a 5.5 millimeter hole there, it leaves quite little material, like 0.25 millimeter per side. Well, that will be nice. But I really hope this succeeds. I really do. So why 5.5 millimeter hole? Well, the reason is that there will be a 5 millimeter ball there. This will be check valve, and then this depth of this hole should be 10 millimeters altogether. Let's see. How is the speed? Well, the speed is alright. Okay, it started straight, which is good. So we need 10 millimeters here. That's it. And now that should be ready. No, it's not ready yet. We need a 3 millimeter drill now, this time. And hopefully this chuck can accommodate it. Well, easily. Good. And now this one needs to be, well, sufficiently deep. This is like the, when the ball is there in the bottom, it will now cover this 3 millimeter hole. And now, I'll put maybe 10 millimeters here, maybe. Okay, there you are. So now I'm well facing this, and then I'm drilling a hole 6 millimeter in diameter to a suitable depth. Well, the suitable depth is, since this is the total length is 52 millimeters, and we had there in the other end the 5.5 millimeter hole, which was 10 millimeters deep. Then we had this 3 millimeters of some depth. So, well, 15 millimeters away from 52, which equals 37. So that's the depth. And the diameter of this hole is 6 millimeters, since we have, it will accommodate a spring like this. And well, let's start. Then there is this needle. Oh man. Oh yeah, now we have a piston, and this is, well, it succeeded well. The O-ring groove, the depth of this groove is really critical. I had to take 2/10 of a millimeter away from the diameter, and now it's tight, but it's I mean, it's like oil tight, but it's still slides easily. So yeah, well, so far so good. Now the bottom piece here. Oh yeah, and there will be a ball, a 5 millimeter ball inside there, which acts as a check valve. It's gravity assisted, so no springs there. Same applies to the one that goes here in bottom. There will be a piece with room for that ball, and then something where you can attach a tube to suck the oil in. Okay, so the bottom piece will be the next. Well, the bottom piece is made of this, well, it's 20 millimeters in diameter, cold rolled mild steel. I just took a piece of that, enough to hold it in jaws. So, yeah. So, as the tradition is, we'll start this up by cleaning the jaws. Yeah, by facing, I mean. And, well, here, maybe. And was it tight enough? I have no intention of moving this after I have done facing, etc. So now let's start. Enough talking. So now we have done the downstairs of this pump. All the components are there now. So the last piece of puzzle was this little... Oh, there you are. Okay. So this thing I made, well, that's one. Well, the next piece, of course, is the top part here, which is just, there was this M8 thread. There is also a ball valve here, and that should be, well, let's see now. Okay, anyway, I will now start doing that one. now drilling a 3mm hole into there. It should meet the bore, the M8 thread there somewhere. Hopefully it does. And now, well, let's see about the speed first. Okay, enough. You don't run these drills slowly. Never. Let's see. Now, let's go. Hopefully it doesn't wander. Well, this drill is dull. It's dull. I have to grind it. Hopefully it is sharper now. I really don't know. Sharpening a 3mm drill is not a trip in the park, really. It's so tiny. Let's see now. Switch the drill on. Yeah. And then we go. Let's see. Well, much better. It's wandering sideways, man. Okay. Not too much left to go. Oh, what was that? Did we break the drill? So, here we have some 3mm thick copper pipe. There is a hole, really. And well, this is going to be the nozzle of the thing. And now I'm just wondering how long. And if it's like too long, then it's really too long. If it's too short, then it's too short. So maybe somewhere there in between. Maybe there. Maybe. Yeah, okay. Then I use this kind of tool, which I just put in there. The thing, was it there? I wanted it to be, yeah, maybe. And then I tighten it and then I just rotate. This is going like that. You rotate it a few times. Actually, this pipe thickness is the minimum this can do. It cannot do, well, now it's all the way in. So we need to break it by bending. So it should go quite easily. It did. Here is the workpiece now. There is the copper tube. And now the next step is to solder it there. And there is this small recess which accommodates some of the solder. Well, this was so tight that it does not penetrate into the gap. I know it already. But nevertheless it will be soldered around here. And I'm using my Metcal soldering iron, which is it's actually quite powerful even though it's small. It's 50 watts. Yeah, okay. One thing about this thing is that the paper here, it's acting as a thermal insulator, so I don't well, it allows this piece to warm up quite well. Now I'm going to use, well, let's see about this solder. I'm warming the copper tube because copper is a very good thermal conductor. And then I'm trying to put this solder down into the gap down there. Well, maybe I should use another type of, let's take this, a lot thicker. let's see what happens with this one. Well, yeah, okay. And now I just let it warm up. It takes some time. I think that's enough. Now we have to wait because the iron doesn't want to wet with this one unless it's really hot. Now it's starting to wet. Yeah. This looks great. Yeah, very good. Oh yeah, there you are. Well, okay, I make this now ready. Let me show you about the quality of the solder joint there. I would say that's really respectable. I'm sure it's all tight. And then we have here at this part there is this O-ring. That's important to avoid it from leaking. I don't want it to drip oil here. I would like it to put it here where it belongs to. So now first we have here two balls. Yeah, why two balls? Well, there is space for two and I don't want there to be extra volume. They take up the volume from there. So that's one ball and another. These are 5mm balls and they go there quite nicely, and then you just put this on. Well. And this doesn't need to be turned very tight. The O-ring takes care of the... And there you are. Huh. Yeah, it's blowing. Yeah. But now, well, let's fill this with cutting oil. Take some time. I will come back when I have done that. I will show you. Wait a minute. There you have it. It's half full, and there is a piece of it says leikkuuöljy. That's cutting oil in Finnish. So I will now fill that bottle. Well, let's see. Well, now the moment of truth. Okay, so here is our product, and this is our oil. Well, don't drink this, even though it's in soda bottle. And now, let's see. One thing that I probably need to do for this is, okay, you don't put it any more than that. Then I have some paper here. Oh yeah, it starts to suck the oil. Yeah, you can see how it sucks it. Okay, now it's coming from there. Well, apparently my camera didn't like this device. Well, I can see it doesn't leak anywhere where it shouldn't. That's a good sign. And well, it squirts oil quite happily, really. Once you get all the air out from there, and well, I believe this is, well, it squirts quite a lot of it actually. So, but yeah. Oh, very important thing. Bye!